This is Mr. Jurdy, and we're live. Let's do some math. You can follow along with me on your worksheet. This is number 6 on the 9.2 worksheet. All right, this is about vacation. The table shows the distance you are away from home over a 6-hour period of your vacation. Let's make a scatter plot of the data. So first thing I'm going to do is look at my x's and decide what I'm going to go by on the x-axis. These are going to be hours. And I'm going to write in here, I'm just going to go by ones because these are just going by ones, and that's going to give me plenty of room here. But I'm going to kind of do something here where I skip a block and write 2, skip and write 4, 6, 8, 10, and 12, just to give myself room, but I still know I'm going by ones. For the y, I'm going to have to figure out what I'm going to go by because I've got to get up to 344. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 spots, and I need to divide that into my total to kind of see what I'm going to go by. So let's do that here. So 344 divided by 12. Mess that up. So 28.6. If you notice down here, here's something that's important. This wants us to predict later on for 8 hours. So I'm going to need a little bit of room to extend my graph out. So I think I'm going to go by 50s. It's still going to cover a lot of the graph. It's not too much bigger than 30. So, and 50s are easy to count by. So I'm going to skip a block and write 100, 200, 300, 400, 500, and 600. Perfect. Now I'm going to plot my points. Plotting 162, just above 50 there. And then 126, right in the middle. 3, 188. Just kind of doing the best I can to estimate where I think that would be. Not perfect, but it's working. 4 is 228. 5 is 280. And 6 is almost 350. Really close. Now I'm going to draw my line of best fit on there. Through the points. Okay, that's a good line of best fit. It goes through the points and it's in the direction they're going. So I have done the first part. I've done A. I've drawn the scatter plot. I've done my line of best fit. Let's write an equation for the line. I'm going to write M equals and B equals because I need those two values. So for the slope, I'm going to start back here and go over and make a big triangle for the biggest one I can make and just kind of see what I get. Looks like it goes over 6. That's going to be where I run. And it goes up. It goes up about 350. I know it says 344, but I'm just going to say 350. I mean, it's an estimation anyway. It's just a line of best fit. It doesn't have to be perfect, but it can be close. So I'm going to do 350 divided by the 6 hours. I'm going to say it's about 58. So I'm going to say my slope is 58. So that'll be y equals 58x plus, this graph pretty much starts at 0. I can't really tell because it's such a big scale, but I'm thinking we started at home, and it kind of makes sense that we would have. So I'm going to put plus 0 on the end. Those are my M and my B. All right, about how many miles per hour do you travel? Well, that's our slope right here. 58 miles per hour. About how far from home were you when you started? I'm going to say, I think we're at home, like we are at home. Gives me no reason to believe that we're not at home or like 1 mile from home getting gas at the gas station, you know, before we take off for our vacation. It's kind of weird that vacations always start at a gas station. Okay, and then we need to predict the distance at 8 hours onto our trip. So I'm going to go at 8. I'm going to go up. That looks like about just shy of 450. So I'm going to say we're probably 445 miles away. And we've answered everything it wants us to answer. Let's try to get 100 likes on this video. Please comment down below. Any kind of comment will do. Math is cool. Subscribe and hit the bell notification. And please subscribe to Jerdy Pie. That's Jerdy 3.14. Southwest 212 over and out!